Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 8.8, Exponential Growth. It says, remember, exponential growth is y equals a times b raised to the x, where a is our initial value, b is our growth rate, and x is our time. So there is a little reminder problem that you can look over if you want to. I would highly suggest that you read over that as well. So now let's go ahead and look at the new problem for us. Since 1995, the daily cost of patient care in community hospitals in the U.S. has increased about 4% per year. In 1995, such hospital costs were an average of $968 per day. Let's list the important information and assign labels for X, Y, A, and B. Well, remember that Y is my total, the thing I'm looking for. So what in this problem are we looking for? Well, the total cost. Okay. The next thing would be the X, which is always our time. Then our A, which is our initial cost, or money. Excuse me. In this case, our initial is 968. And then B is our growth rate, which our growth rate would be 4%. I'm sorry, you need to write growth rate, don't I? B is our growth rate, which is 4% or 0.04. Okay? So now we need to go ahead and write an equation to model the cost of hospital care since 1995. We are not going to know a time because it does not tell us how many years in the future that we're looking at. But we can do Y equals our initial amount, which is 698, times, now 1 is going to be the total amount that has already been accrued or already happened. So I'm going to do 1 plus my growth rate, which is 0.04. I'm going to raise that to the number of years of x. Okay? So let's simplify this equation out a little bit. We'd have 698 times 1.04 raised to the x power. So now it says to use the equation that we wrote, which is that second one we just wrote, to estimate the approximate cost per day in 2010. So what I'm going to do is I'm going to take y is equal to 698 times 1.04 raised to the number of years. Well, from 1995 to 2010, that would be 15 years. Okay? So now that I have that written out, what I need to do is take my 968, times the 1.04 and raise the 1.04 to the 15th power. I can type that straight through in my calculator exactly the way it looks. I will get y equals $1,743.31 a day. So it went from $968 in 1995 to $1,743.31 in 2010. So suppose, so that's the end of that problem, I'm sorry. Now it gives us a new problem. It says, suppose your community has 4,512 students this year, which at that time it was 2008. The student population is growing at 2.5% each year. After defining variables, write an equation that represents the student population and what will the population be in 3 years. So we need to list the important information. So the important information, our y is going to be our total students at the end of our amount of time. X is going to be our time, which in this case will be 3 years. A is our initial amount, our initial population, which in this problem is 4,512 students. And B will be our growth rate, which in this case is 2.5% or 0.025. Okay? So now we need to write the equation. So y, will equal our initial amount, which is 4,512, times, again, it's going to be 1 plus, because we're growing. So the 1 would have been the amount of students at the original time, right? Plus my growth rate, which is 0.025, raised to our x. Or, in this case, we know what our x is. It's 3 years, so it's raised to the third power. I want to simplify that equation a little bit, so y equals 4512 times 1.025 raised to the third power. If I type that straight through my calculator, the way it looks, my answer would be 4,859 students. Whenever you have a problem like this, you're going to round to the nearest whole number if it's population. If it's money, you're going to round to the nearest 2 decimal places. Okay? Let's go ahead and look at the back. Compound interest. Compound interest is exactly the same idea as what we just talked about. And we are going to work through it exactly the same way. So suppose your parents deposited $1,500. That's my A value, in an account paying 3.5% interest compounded annually, so that's my B value. Annually means that it's going to compound once a year, or it increases by 3.5% once a year. Okay? Let's list the important information. Well, our Y is going to be our total amount of money that we're going to find. Our X will be our time. They haven't told us how many years down the road we're looking at. Our A is our initial amount of money, which in this case is the $1,500. And our B is our growth rate, which in this case will be 3.5% or 0.035. Write an equation to model the total amount of money in your account. We don't know how many years it is, so in this case we still have to use X for X, okay? So our total amount is going to be Y equals our initial amount, or the $1,500, times 1 plus, since it's growing, 0.035 raised to the X, because we don't know how many years it is. We want to simplify our equation, so Y equals 1,500 times 1.035 raised to the X value. Now it asks us to use our equation to find the balance after 18 years. So it would be Y equals the 1,500 times 1.035 raised to the 18th. Type that straight through on our calculator, and we are going to end up with Y equals $2,786.23. And because that is an amount of money, remember I will round to my second decimal place. Okay? Well, what if your interest is compounded more than once a year? What if your interest grows? What if your money grows by our growth rate more than once a year? Well, I'm going to take my growth rate, or my interest rate, and divide it by the number of interest periods per year. Okay? So let's look at the next problem. It'll make more sense after we kind of look at a problem. Let's say that the account in the above example paid interest compounded quarterly instead of annually. Well, quarterly means it's going to compound 4 times in 1 year. We need to find the account balance after 18 years. Well, since we are using our interest 4 times each year, I then need to take my 18 and multiply that by 4, because there will be 72 periods in which I use my growth rate. Okay? So which variable, in this case it would be variables, are going to change in value? It's going to be my B value. It's going to change from, what was that, it's going to change from 0.035. I will divide that by 4, which would get me 0.00875. And my X value is going to change from 18, because I have to multiply by 4, to 72. So both my B and my X values are going to change here. So now we need to rewrite our equation using our new information. So it'll be Y equals the 1,500 times 1 plus my new B value, 0.00875, raised to the 72nd. So now I'm going to simplify that out a little bit. Y equals 1500 times 1.00875 raised to the 72nd. If I type that straight through into my calculator, I end up with $2,808.71. So you notice that the difference between being compounded quarterly, my number is going to be higher. The amount of money I have in my account is going to be higher than if I only had my interest compound once a year. Okay? You deposit $200 into an account earning 5%, compounded monthly. After defining variables, write an equation that models the situation. How much will be in the account after 1 year? Well, since it is monthly, 1 year is really 12 months. 2 years is really 24 months, and 5 years is really 60 months. We really need to know that information, because if we don't use that correctly, our time's going to be off, which means our equation is going to be off. So our Y will be the total amount of money. Our X will be the time. Our A will be the initial amount of money, which in this case is going to be $200. And our B is going to be our growth rate, which will be 5% or 0.05. Okay? So we need to write our equation. We don't know how much time because there's 3 different times that we're going to have to use. So I'm going to have Y equals the initial amount, which is 200, times 1 plus my growth rate. My growth rate in this case is 0.05 raised to the X value. Again, I want to make sure that I simplify that sum, so Y equals 200 times 1.05 raised to the X value. Now it asks us, what is our amount of money after 1 year? Remember to use 12 instead of 1 for this. I'll have Y equals 200 times 1.05 raised to the 12th, which would get me $359.17. I'm rounding to 2 decimal places here. Again, for 2 years, it would be 200 times 1.05 raised to the 24th, which is $645.02. The last one is 5 years, so 200 times 1.05 raised to the 60 months is going to be $3,735.84. So that's why we use exponential growth. We have gone through our entire story problem lesson here. Remember that if we have a story problem, what we're going to do is take our initial amount times 1 plus our growth rate when it is increasing. And we're going to raise that 1 plus the growth rate to the amount of time. If you have any questions over this lesson, please make sure you come in and talk to me. Don't sit around confused. Otherwise, thank you very much for watching the video, and have a great day.